In section 6.4, we cover permutations and combinations. So now we can apply the generalized multiplication principle to the solution of two types of counting problems. Both types involve determining the number of ways the elements of a set can be arranged, and both will play an important part in the solution of problems in probability. So first, let's go back and take a little bit of a look at what we did in section 6.3. So our very first example says there are 7 people waiting in line. How many different ways can they stand in line? And we did this kind of question in the previous section. So if I have 7 people that I need to put in a line, that gives me 7 choice blanks. So when I go to put the first person in line, all 7 are standing over there. I pick one of them, I put it in spots. I have 7 to choose from. Now, one person is in line. I'm going to go back over to my group. Well, I've only got 6 left to choose from. So I have one of those 6 that's going to go in that spot. Then there's 5 left to choose from, and 4, and 3, and 2, and then 1. So the number of ways to put 7 people in a line is 7 factorial, which comes out to be 5,040. So it just so happens that in mathematics, when you start off with the number n, and you multiply it by every number smaller than it, so 1 less than that, 1 less than that, times dot, 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 all the way down to 2 times 1, that's considered to be n factorial. So this exclamation point over here is a factorial symbol in mathematics. So factorial simply means if there are n objects, then the number of ways to arrange those objects in a row is the product of all the natural numbers, those are the numbers you count by, from n to 1 inclusive. So that means including n and including 1. And that's what a factorial is. So let's get some practice on our calculators using factorial. So example 2 has several problems where we're just going to try it on the calculator. So the very first one is 10 factorial. So on your calculator, what you're going to do is first type in the 10. Then you're going to go to a math key. When you hit that math key, you'll see several options across the top. I need you to arrow over to PRB for probability. And then when you list probability, you'll see several things listed there. Okay, number 1, we're not going to need. Number 2 says NPR, which we'll use in a bit. Number 3 is NCR, which we will also use in a bit. And then finally, number 4 is that factorial symbol. So once you arrow down to number 4, you're then going to hit enter. And now what you should see literally is that exclamation point. So now on your screen, you'll have a 10 and that exclamation point, and then hit enter. And that'll give you the answer. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 comes out to be 3,628,800 ways to arrange 10 objects, all 10 objects. Okay, let's try another one. And at this point, you're just getting practice using that calculator. So the next one I want to try is 6 factorial. So again, you're going to type in the 6, then you're going to go to math over to probability, down to number 4 with the exclamation point, then hit enter, and then hit enter again. And you should find out that 6 factorial is equal to 720. If you don't have a graphing calculator, you may still have that math key. So I encourage you to look at it. If you can't find it on your calculator, then contact me and we'll investigate together. So the next one asks us to figure out what 0 factorial is. Well, if you do this on the calculator, you're going to end up with 1. Now, this is a definition. We end up having to define 0 factorial as a 1 to avoid dividing by 0 when we do permutations and combinations. So this is a definition. So it may not make sense from our definition up here, but we do define 0 factorial to be 1. And then 1 factorial is also equal to 1. And your calculator will tell you both of these if you type them in. Then the next one asks us to figure out 7 factorial divided by 3 factorial. When you go to do this, make sure you put that denominator in a set of parentheses. And what you should end up with 840. The longhand way of doing this would be to take 7 times 6 times 4 times 3 times 2 times 1 all over 3 times 2 times 1. Well, these are going to cancel. So you could literally just take 7 times 6 times 5 times 4. And that would also give you the same answer. And then finally, 5 factorial over 0 factorial. Well, that's 5 factorial divided by 1, because we defined that. And that comes out to be 120. Okay, the other piece of background information we need is to take a look at whether or not order matters when you're picking or arranging the objects. So to give you an example of when order would matter, let's take a look at the letters A, B, and C. So what we want to do is consider how many pairs, pairs meaning two, right? How many pairs of letters can we create from the set A, B, C? What we're going to do is literally make a prediction. So let's use that multiplication principle to make a prediction. So here's the first letter that we're going to pick. Here's the second letter that we're going to pick. So the very first letter would be, I'm sorry, you'd have three choices, either the A, the B, or the C. So that would be three possibilities. And the second letter would only have two possibilities because you've already used this one. So when we do that, we say that there are 6 possibilities. Well, let's list them out. So I could do an A with a B. I could do A with a C. I could do as another possibility B with an A or B with a C. And then the other possibility would be C with an A or C with a B. So each of these represents a pair of letters picked from the set A, B, C. And sure enough, we have 6 of them. So in this case, when the order matters, also there are no repeated objects. So I didn't repeat an A with an A or a CC. So no repeated objects. And then finally, they're distinguishable, which means you can tell the difference between them. So distinguishable. Again, that means that you can tell the difference between your objects. So an A is different from a B, and a B is different from a C. So they're distinguishable, like people would be distinguishable. So in this case, when all these things are true, this is considered to be a permutation. So if these are all true, we end up with something called a permutation. So anytime you are ranking things and giving them a specific spot, like putting people in a line, ranking them as first, second, third, giving them a title as president, vice president, secretary, treasurer, those are ranking things and implying an order. Okay, now if the order does not matter, then the AB and the BA are the same. If order doesn't matter, then AC and CA are the same. And then BC and CB would be the same if the order doesn't matter. So if order does not matter, there are still no repeats. And they are still distinguishable. You can tell the difference between them. Distinguishable. Then it's a combination. So when order matters, it's a permutation. When order does not matter, it's a combination.